Okay, so today we're going to be talking about the Pythagorean Theorem. Alright, Pythagorean Theorem is used to verify if right triangles are truly right triangles when you're given three sides. And it can be also used to find a missing side of a right triangle when you're giving two of the other sides. Alright, so just a quick little thing to note is that on your SOL formula sheet, they're going to give you the Pythagorean Theorem. It's down here in the bottom right. They're going to give you a picture of the right triangle with A, B, and C on it. And they're going to give you a squared plus b squared equals c squared. That is your Pythagorean theorem. In other words, kind of like a formula in a sense. Right? So they give that to you. Now, on the note sheet, we're going to start in the parts and proofs section. So look at the parts section on your note sheet. Right? So when we look at a right triangle is made up of three different sides. Right? Two of the sides are known as legs. These are your legs. The legs make up and form the right angle. So the legs connect and form a right angle. That is your legs. The longest side opposite the right angle, so the longest side opposite the right angle is known as your hypotenuse. And so it's really important to remember that this is your longest side. Right? The legs will be A and B, and the hypotenuse will be C. So in the formula, a squared plus b squared equals c squared. A and b are your legs, and c is your hypotenuse. So a, b, and c. And a and b can be alternated, be switched. Right? This can be b and this can be a. Those don't matter. It's just the longest side has to be c. Right, now, with the proof, right? Proof states that in a right triangle, the sum of the squares of the legs is equal to the square of the length of the hypotenuse. And so what that looks like visually is this. Right? So if I had a right triangle with the lengths of 3, 4, and 5, my legs would be 3 and 4. If I drew a square that had the lengths of 3, 3, 3, and 3, took the area of that, the area would be 9. If I drew a square off this side, and each side was 4, 4, 4, and 4, the area would be 16. What this formula is stating is that the sum, so when I add 9 plus 16, when I add those those two numbers, 9 and 16, those two areas, they should equal the area of the hypotenuse, the square formed by the hypotenuse. So we look at the hypotenuse was 5, so 5, 5, 5, and 5, the area would be 25. So when I do 5 squared, it gives us 25. Well, 9 plus 16 equals 25. And that's where the formula for a squared plus b squared equals c squared comes from. Because to find the area of the squares, we do the sides squared, or s squared. So in this case, a squared plus b squared equals c squared. So 9 plus 16 equals 25. Right? So we can put this into practice, and we can use this to verify if a given right triangle is in fact actually a right triangle. So in other words, we can check to make sure that this picture is correct and that these sides actually form a right triangle, because sometimes numbers given to you, sides given to you, don't actually form a right triangle. So we can use the formula a squared plus b squared equals c squared. So the first thing I would do is I would label, because sometimes the triangle might be flipped around and turned, I would label your sides that are A, B, so your legs, I would label your legs, and then I would find your hypotenuse, the longest side, the one opposite the right angle, the longest side, and I'll label that C. Now if you don't have a picture, and they just give you three numbers, you can still check it, knowing that the longest side has to be C, and then the other two could be A or B. It doesn't matter. As long as the longest side is C, that's all that matters. So now that I have what my A, B, and C are, I substitute in. So 15 squared plus 20 squared equals 25 squared. So now we just need to solve this equation and find out if both sides equal. 15 squared is 225, 20 squared is 400, and 25 squared is 625. 225 plus 400 gives us 625. And 625 comes down. And so now we look at it, 625 equals 625. That is a true statement. So therefore, this is a right triangle. So it is correctly labeled. It is a right triangle. And this work is what justifies our answer. Right? So now, flipping on to the back, the other two examples we have are finding missing sides. So in this first example, it says we're going to be finding the hypotenuse. So in other words, we're finding the longest side. So when we solve this, we should know that if we're finding the hypotenuse and we're finding the longest side, our answer should be bigger than 30 and 40. If we get something less than 40 or less than 30, we know we did something wrong. So in finding the hypotenuse, we need to first label just our sections. This is a leg, so this could be A. This is a leg, so this could be B. And this is our longest side, so therefore it is C. So then we can substitute it into our Pythagorean theorem of a squared plus b squared equals c squared. 30 goes in for a squared, 40 in for b, and then we do not know c yet. That's what we're trying to find. 30 squared equals 900, 40 squared equals 1,600, and we just bring down the c squared. 900 plus 1,600 gives us 2,500 equals c squared. Now, this is where we have something new. So if we want to get rid of c squared and get c completely by itself, we need to do the opposite of squared. So the opposite of squared is taking the square root. So if we take the square root of both sides, c squared and the square root cancel each other out, and it gives us just c by itself, and then the square root of 2,500 is 50. So then, in this case, in this problem, our length of our hypotenuse, or c, was 50 inches, 50 feet, whatever units that we're using. Now in this last example, we're finding a missing leg. So you see we're finding A or B, doesn't matter. Right? So once again, I would label your sides. 8 connects with the right angle, so that we can make 8A, X, which is the right angle, so we can make XB, so we have A and B, our legs. And then 16 is the longest side, opposite the right angle, so therefore that is C. Right? So now we can substitute into our Pythagorean theorem of A squared plus B squared equals C squared. A can go in for A, plus our b squared, we do not know b, equals c squared, which is 16 squared. A squared is 64, the plus b squared comes down, 16 squared is 256. To get rid of 64, we subtract 64, and then we're left with b squared equals 192. So just like we did in the last problem, to get rid of squaring something, so b squared, the opposite of squaring would be the square root. We're going to take the square root of both sides, and when we do that, we get b equals, and the square root of 192 gives us this crazy decimal, so we'll round it to the 10th. When we round it to the 10th, we get 13.9. So then the length of this leg is approximately 13.9 units, inches, feet, whatever it is. Right? Key thing to remember is just note that this is your Pythagorean theorem. A and B are your legs, so the shorter sides, and C is always the hypotenuse, or the longest side of the triangle.